Source of water pollution. What is water pollution? Water pollution is degradation of water quality. The primary water pollution problem in the world is lack of clean, disease-free drinking water, cause epidemics of waterborne disease like cholera. Types of water pollution. First, point source occur when harmful substances are emitted directly into a body of water. Second, non-point source delivers pollutants indirectly through environmental chains. Source of water pollution. First, sewage and wastewater. Second, agricultural. Third, oil pollution. Next, radioactive substance and river dumping. Sewage and wastewater. Sewage is another name for wastewater from the domestic and industrial process. It comes from our sink, showers, and toilets, and from commercial, industrial, and agricultural activities. According to United Nations, more than 80% of the world's wastewater flows back into the environment without being treated or reused. Agriculture processes such as uncontrolled spreading of slurries and manure, disposal of sheep dip, tillage, plugging of the land, use of pesticides and fertilizers can cause water pollution. When rains, fertilizers, pesticides, and animal waste from farms and livestock operation wash nutrient and pathogens such as bacteria and viruses into our waterways. Oil pollution. Oil spillages affect water quality in a number of ways. Oil can make drinking water unsafe to drink. A substantial amount of oil released into ocean and seas will destroy wildlife and the ecosystem that sustain them. Oil spills also reduce oxygen supplies within the water environment. Radioactive substances used in nuclear power plants, industrial, medical, and other scientific processes. It also occurring radioisotopes from organisms and within the environment. If not properly disposed, radioactive waste can result in serious water pollution incident. River dumping. Lots of people dump supermarket trolleys, bicycles, garden cutting, and electronic waste into rivers or river banks. River dumping not only causes water pollution, it also harms wildlife and increases the risk of flooding. How to mitigate water pollution from source of water pollution? First, how to mitigate water pollution from sewage and wastewater? Minimize water use when it's raining. Wait to wash clothes or run the dishwasher until the rain stops to lessen the burden on the sanitary system. Do not pour fat from cooking or any other type of fat, oil, grease down the sink. Dispose trash properly. When trash is not disposed properly, some of the non-degradable products, such as diapers and sanitary towels, may end up destroying the process of sewage treatment. How to mitigate water pollution from agricultural? Use current nutrient management guidelines for a specific crops. Time applications and determine amounts according to plant needs. Irrigate according to plant needs. Use measurements of soil moisture content or local evapotranspiration data to guide the frequency and amount of irrigation. Use an irrigation system which delivers water uniformly. Inspect water delivery during irrigation to be sure nozzles aren't clogged. How to mitigate water pollution from oil pollution? Using oil booms. The use of oil booms is a very simple and popular method of controlling oil spills. These booms act like a fence to prevent the oil from further spreading or floating away at the sea. Reuse automobile oil as much as possible and keep your vehicle well maintained. Reusing automobile oil reduces the amount of used oil that is discarded, which may end up polluting water bodies. How to mitigate water pollution from radioactive substance? Proper method of disposing of radioactive waste. Radioactive waste still has some level of radiation. It cannot be disposed of in the same way as normal waste. It cannot be incinerated or buried. This waste should be stored in heavy and thick concrete containers. Reusing the radioactive substance. Since it is not easy to store or dispose the waste, it can be recycled and used for other purpose like in another reactor as fuel, thereby protecting the environment. How to mitigate water pollution from river dumping? Skip the use of plastics. Plastic leftovers frequently end up in the oceans, lakes, streams, and rivers. Set up a garbage trap downstream of the river. For example, garbage trap at Klang River. Exposing the importance of rivers to the society through campaign. Avoid direct dumping into water systems, which should desist from disposing rubbish or any other waste products into rivers or lakes.
I will explain and demonstrate how to measure the BOD, step by step. First of all, you must to obtain a water sample from any source you intended to test for its biological oxygen demand BOD. Each sample should consist of 2 sets of bottles. 1 bottles will be tested on day 1. The second set of bottle will be stored for 5 days. Second, prepare dilution water by adding 1 milliliter of phosphate buffer, 1 milliliter of magnesium sulfate, 1 milliliter of calcium chloride and 1 milliliter of iron 3 chloride solutions to distilled water and bring the volume to 1 liter using a volumetric flask. Next, dilute sample to an appropriate dilution factor using dilution water. The formula of dilution factor is volume of sample divided with the final volume of sample and dilution water. Next, mix and aerate the diluted sample until saturated with air. Slowly pour the diluted sample into a clean BOD bottle without creating air bubbles. Allow the water sample to overflow the neck of the bottle and insert the stopper firmly. After that, you must to prepare 2 sets of BOD bottles filled with the diluted sample. Each set is composed of 3 bottles. Label the bottle with set 1 and set 2. Third, incubate set 2 at 20 degrees Celsius for 5 days with using the aluminium foil. For the bottle of 1, add 1 milliliter of manganese sulfate, MnSO4, solution followed by 1 milliliter of alkali iodine solution with the pipette tip below the water surface. The purpose is to fix the sample so that oxygen exchange will not occur during testing. Next, place the stopper firmly to exclude air bubbles and mop up any overflow of water with a tissue. This could be alkaline, so take care. Holding the bottle with a finger on the lid, shake the bottle vigorously. Fourth, when the precipitate has settled sufficiently about half of the bottle volume to leave clear superate above the manganese hydroxide flock, add the 1 milliliter of concentrated sulfuric acid, H2SO4, using a dropper pipette with the tip below the water surface. Next, place the stopper and mixed thoroughly until the precipitate dissolved and iodine has been released to give a clear reddish-brown color. Pour the sample into conical flask for titration. Titrate with the 0.025 molar sodium thiosulfate, sodium sulfide O2, solution to a pale yellow color. After that, add a few drops of starch solution, and deep blue color is formed. Continue the titration until the blue color disappears and note down the Barrett final reading as D1. Repeated steps 4.3 and 4.4 to obtain 2 more reading for D1. Fifth, you must to prepare 2 sets of BOD bottles that each set should consist of 3 bottles that filled with dilution water saturated with air for blank. Label as Set 1 and Set 2. Set 2 will incubate at 20 degrees Celsius for 5 days in incubator. For Set 1, repeat steps 4.3 and 4.43 times to obtain 3 readings for blank B1. In step 6, you must to determine DO for sample D1 and blank B1 on day 1. 1 milliliter of 0.025 molar sodium thiosulfate, sodium sulfide O3, is equal to 1 milligram per liter of DO for sample on day 1 from the titration. DO for blank in day 1 is the amount used of 0.025 molar sodium thiosulfate, sodium sulfide O3, for titration in ml is equal to the amount of DO in milligram per liter. After 5 days, take out the both set B from aluminium foil and incubator which is diluted sample, D2 and blank, B2 that contain the diluted water saturated with air. Repeated the titration steps to determine DO for sample D2 and blank, B2. Next, determine DO for sample and DO for blank on day 5. The amount used of 0.025 molar sodium thiosulfate for titration in milliliter that equal to the amount of DO in milligram per liter. Lastly, after you determine the amount of DO for sample and blank for day 1 and day 5, you can calculate the biological oxygen demand, BOD, by using the following formula where the D1 is initial DO in a sample, D2 is final DO in sample, B1 is initial DO in blank, B2 is final DO in blank, and P stand for fraction of BOD bottle that is represented by the sample or milliliter pipetted divided by 300 milliliters, when you use the 300 milliliters bottle.